Okay, so how's school?
Good. Yeah, we're doing square roots right now. Just simplifying square roots right now.
Okay, good. We can work on some of that tonight if you'd like.
Sure. Yeah.
So you're pretty much just reviewing algebra.
Yeah, pretty much. I think it's like the first few weeks is just review.
That's fine.
Yeah.
How do you like your new teacher in geometry? What's the
I do.
what's the name of your new teacher?
Mr. Magus.
Ah, Magus. How do you spell that?
Majes, I think.
Is that the same teacher that Cole White has?
I believe so. I'm not in his class,
I
like his
asked
period
him,
class.
asked him once, and he gave me a name, and that sounds familiar uh,
Okay.
with that name.
There's a lot of names similar to that. There's like Mosier,
It was
Magus.
Mosier. It was Mosier. That's
It wasn't Mosier.
yeah.
Okay.
His teacher is
Okay.
Mosier. That's what it.
Cool.
Okay, so let's talk about radicals.
Okay. Sure.
Simplify that for me. This is the kind of stuff you're doing.
Yep, exactly.
Okay.
So this is simplified to square root of 9 and then square root of 8. And then it would simplify to 3 square root of 8.
About square root of 8. Can we simplify that?
No.
Actually, we can't. It's the
Okay.
square root of 4 times the square root of 2, notice.
Oh, okay.
Okay? And since that is a perfect square, we can pull another 2 out,
Mm-hmm.
multiply the 2 times the 3, and we end up with 6 root 2.
That
So
makes sense.
this is
Okay.
actually the answer. Okay?
Okay.
In other words, you
Alright.
always have to simplify it all the way down.
Okay.
One of the things that is worthwhile is when you factor this quantity,
Mm-hmm.
you want to factor it into one of the numbers has to be a perfect square number, which you did when you separated it into 9 and 8.
Mm-hmm.
But
Yeah.
notice that it also separates into this.
Okay.
In other words, 2 times 36 is 72 also, and 36 is a perfect square number. So
Yeah.
I
Okay.
can go directly from that to that without any intervening steps.
That makes sense. Okay.
So the trick, it doesn't really matter if you find the greatest perfect square.
Mm-hmm.
In other words, you can do it in pieces if you want.
Yeah.
It's just more steps. But
Yeah.
you have to also make sure that when you get down to a final piece, that it is a final piece. In other words, in the last problem, you had 3 square root of 8. Well, that's never simplified.
No.
And
Okay.
you'll learn that as you work with some of these. That square root of 8 always can be reduced. Square root
Okay.
of 10? No.
Mm-mm.
Why is
No.
the square root of 10 not reducible?
Because there's no perfect square that goes into 10,
Yeah, it's the square root of 5 times the square root of 2.
which
But,
both don't have a.
right, neither of those is a perfect square. Both of them are prime, so they can't go
Mhm.
down any further, so that doesn't reduce.
Okay.
Let's look at this one.
Okay. We could simplify that to a square root of 100 and a square root of 2, and then it'd just be 10 square root 2. Or 10 radical sine 2, yeah.
No, you did it perfect.
Cool.
Exactly what I'm looking for.
Okay. Okay. Is that a 1 right there?
Yes.
121? Okay.
21.
Alright, let's see here. Two numbers that go into that. Um, Well, we know that 11 times 11 goes into it, but it's not a perfect square.
Actually, it is. 11 times 11 is 121.
So just be...
It's 11.
Oh, that makes sense. Okay.
It's kind of a trick.
That's kind of...
It's kind of a trick question. In other words,
Okay.
that is a perfect square number. Not everybody would recognize it, but it is a perfect square number.
Okay, it's cool. This would be 3 over 2.
Good. In other words, square root of 9 over square root of 4 is the first step.
Mm-hmm.
And that's 3 over 2. Okay.
Cool.
You seem pretty comfortable with radicals.
Yeah. We haven't done that quite yet.
Okay.
How would you do that?
Yeah. Well, in other words, if I want to separate this, I could do it this way. Right?
And the next one. Yeah.
And what's the answer to that? What I have circled? What's
The
the
answer to that would just be x to the 4th.
No, what's the square root of x squared?
Just x. Well, yeah, just x and then x. Okay.
Okay. In other words, I still have this square root of x left over, but I can pull a full variable out of there.
Okay. Oh, I'm sorry. I was kind of zoning out there. So that could be x squared, like square root of x squared, and then another square root of x squared.
Hold on. You had the right answer, what you first said.
Okay, just leave it like that.
That's the answer.
Okay.
And the reason it's the answer is because x squared times x squared is equal to x to the 4th.
Mm-hmm.
Okay, so variables, what you generally do is divide the variable by 2. In other words, if I had x to the 5th, what would that be?
Just x to the just x to the 5th, I guess.
Okay.
Could you?
Separate. In other words, the answer to all radical problems is to separate it. So let's separate it into x to the 4th times square root of x, right? You can always do that. In other words, the square root of a times b is always equal to the square root of a times the square root of b.
Okay.
So these steps, this is the essence of what you do to solve these problems. And now we just did this one. What's that?
That'd be x squared.
So the answer?
X squared to x, okay.
X squared times root x.
Okay.
That's the same as this.
Perfect.
All right.
All right.
I thought probably I was looking in the book and I realized that last semester, even in the honors class, you covered chapters 1 through 8. And the next 2 chapters are right triangles and circles, which is what we've been doing a lot of.
Yeah, for sure.
So that should be helpful to you because I'm pretty sure that's probably what you'll get to next. I might be wrong.
Probably.
But I thought maybe what we'd do tonight is just kind of review the stuff that I've given you homework on over the last 3 weeks. And let's just make sure you can do some of these. Hold on.
Perfect.
I'll just randomly pick
Okay.
and ask you to solve. So how about 62?
Okay.
10x equals 5x plus 5.
Alright, so what we could do, we could subtract 5x from both sides, so we get negative 15x is equal to 5. And then you divide by negative 15 on both sides. And then that would be simplified to x is equal to 1 negative 3, or negative 1/3.
Perfect. The last answer.
Yeah.
In other words, it's important to know that this is the same thing as minus 1 over 3. It's also the same thing as 1 over minus 3. And it's also the same thing as minus 1/3. All
Okay.
of these are the same thing.
Mm-hmm.
It does not matter where the negative sign is. And therefore, what we do is we want to choose that one.
Mm-hmm.
In other words, this is negative 1/3. It's not really negative 1 over 3.
Mm-hmm. Yeah. Okay.
About this one.
Okay. So what we could do is subtract 19 from both sides.
Okay.
So you would get negative 20, negative 3/4 equal to negative 21. 29. Wait, 19. 30, negative 31, my bad.
Negative 30.
Oh yeah, my bad.
Okay. Now what?
Alright. And then we would divide by negative 3/4 from both sides.
Okay.
And then
how do you solve
you would
that
get
right there? In other words, we know x is on that side.
Mm-hmm. We could do negative 30 times negative 3 divided by 4.
You got to flip it.
Negative 30 times 4 divided by 3.
Right. You cannot multiply. You cannot turn it into a multiplication problem unless you flip it. In other words, if I just straight multiply minus 30 times minus 3/4, it can't possibly be the same thing as this. Because this is minus 30 divided by minus 3/4.
Yeah.
So what about the negative signs? What should I do with those negative signs?
Well, you can go ahead and cancel them out because it's
Perfect.
2 negatives.
That's what I wanted to hear.
Cool.
In other words, get rid of them immediately.
Yeah,
now
definitely.
We have 30 times 4 over 3. How am I going to do this problem?
It'd just be 120 divided by 3, which is 40.
No. I don't want you to do it that way.
Okay.
I want you to simplify it before you do the multiplication.
Okay.
What's 30 divided by 3?
10.
So let's do that.
Okay.
What's the advantage
So
of
just
that? The advantage is I never had to deal with a number greater than 40. Whereas
it
the
just
way you
saves a step.
did it, you multiplied 30 times 4, and all of a sudden you have this number 120.
Mm-hmm.
Just the general rule that I think is very helpful is always reduce before multiplying or dividing.
Okay.
Okay, if I have something like this, and I am multiplying it by something like that, well, I could multiply it, and I got huge numbers. But I can also reduce it. In other words, 35 over 70 is the same as 1 over 2. 4 over 8 is the same as 1 over 2. So what I really have is 1/4. And I got it without dealing with any big numbers at all.
Yeah.
Now, I suppose if a calculator is always at your hand, these kind of tricks don't help that much, but nah, I still like to suggest them. Okay, how about 67?
Okay.
I'll write it out here.
Sure. Okay. So for this one, let's see here.
What's the problem with this equation? Why
No,
is this difficult?
there are no common denominators.
It's a bunch of fractions.
Yeah.
That's really why it's difficult. Is that there's a bunch of fractions.
Yeah.
So let's get rid of all the denominators in one step.
Okay.
What can I multiply both sides of the equation by to get rid of all four denominators?
12.
Good.
Cool.
What's that side by 12?
That side would be, let's see here. So we would just do 12 times 5.
No,
Sure.
don't do it that way.
Okay.
Do 12 divided by 4.
3. Oh, okay.
And 3 times 5.
Okay. Which is 15.
Okay. Isn't that easier to do?
Yeah, much easier.
Okay. And then how about this number here times 12? Same process. What does that become?
12 times 4 divided by 3.
No, 12 divided by
12
4.
divided by. Yeah, so it'd just be negative 3 over 3.
Okay, it'd be 3 times negative 3.
Oh, okay, so it'd just be negative 9.
And then
Okay.
if we check it, is 3/4 of 12 9? Yes.
Yeah.
But if I came up with an answer like 3 over 3, that's the number 1.
Yeah.
Well, 3/4 times 12 can't be 1.
No.
So use this ballpark checking.
It's like common sense, kind of.
Yeah, exactly. In other words, every single time you make a step, make sure that it makes sense.
Okay.
Okay, now, because I multiplied the left side by 12, got to multiply the right side by 12 also. What do I get?
Okay, so it would be 10x, and then plus 6.
Okay. Now, if I would have started with this problem, it wouldn't have been much of a problem. I wouldn't have even given it to you. It was so easy.
Yeah, exactly.
So the moment you can get rid of all your denominators, especially when you can do it with one number, that's what you want to do.
Okay. Cool.
All right, let me see if I can find some other. Same thing over here. What number am I going to multiply both sides by in number 66?
40.
Yes.
Cool.
That is the least common denominator between 8, 5, and 4. In other words, whatever number you come up with, it doesn't have to be the least. Incidentally, I could multiply everything by 80. And I still get rid of all my denominators. The difference would be I would have bigger numbers. So that's the advantage of multiplying both sides by the least multiple. All right.
Okay, cool.
Let me go to a different page here.
Okay.
Let me make sure some of these still make sense.
Sure.
Inequalities, I don't think we need to review. I noticed that when you did these on your homework, you did them exactly correct, even though we had never done any of these.
Yeah.
In other words,
it's just like.
Go ahead.
Yeah, it's just kind of the same as just like as an equal sign instead of the equality sign.
In other words, what is the same is that I can do anything I want to that, and that as long as it's the same. In other words, for 37, I can add 7 to all 3 parts. I can add 7 to that, I can add 7 to this, and I can add 7 to that. And then I end up with x greater than or equal to 5, less than or equal to 18. And that's my answer. So I feel like you know how to do these. Let's not redo those.
Okay.
Yeah, that's good.
Cool.
What's the slope for number 20?
For number 20, it would be. Here we go. -1, 1. Because it's y,
Okay, hold on.
yx, yeah. So it'd be n is equal to
I'm
y.
going to suggest doing it the same way every time.
Yeah.
Always do it this way.
Mm-hmm.
What I mean by that is that even though you can do it this way,
Mm-hmm.
I think that just confuses you.
Yeah.
Either of those is correct.
Okay.
But you cannot switch them. You can't do that in the numerator and this in the denominator.
No.
So to avoid any confusion, let's just always do it y sub 2 minus y sub 1. Okay. Now, fill in the blanks on number 20. In other words, this is the way I'd like you to do it. When I just asked you what that was, you did the whole thing in your head instantly. I don't want you to do it that way.
Okay.
I want you to do it this way. What's y sub 2?
So y of 2 would be 3.
What's y sub 1?
2.
What's x sub 2?
-4, and then 3.
Now, let's fill in the numerator. What's the numerator?
1.
What's the denominator?
-7.
What's the net answer?
The what?
What's that turn into?
-17.
Okay, perfect.
Cool.
In other words, as long as you did it step by step, you had no problems at all.
Yeah.
So you know how to do it.
Mm-hmm.
Your only danger is trying to do it too fast.
Okay. Yeah, that makes sense.
Okay? Because you got it when we went through it step by step. You didn't get it when you tried to do the whole thing in one step.
Mm-hmm. Yeah.
Let's do this one here. 29.
Okay.
Fill in the blanks.
So y sub 2 would be 5, just 5 halves. And then y of 1 would be 0.
No.
Oh, just 7 over 2, my bad. Yeah. Over 2 minus 0.
What's 5 halves minus 7 halves?
So that would be -2 halves, which it would just be 1, so it'd be just 1 over 2.
Don't drop the negative sign.
-1 over 2, yeah, my
Negative
bad.
1 over 2, which is -1 half.
Yeah.
Okay, cool.
Awesome.
Yeah, no, I'm happy. You're learning this stuff.
Mm-hmm.
And you're retaining it, more importantly. We're
Yeah.
not just learning it for one day.
Mm-hmm. Exactly.
Let me just look at some of these first.
Okay. All right.
Number 31, what's the y-intercept?
10.
What's the slope?
6.
On 32, what's the slope?
-9.
What's the y-intercept?
Just 0.
Good. On 33, what's the y-intercept?
100.
What's the slope?
Just 0.
Really good.
Cool.
On 34, what is the slope?
-2x, and then it would be.
Hold on. Just -2.
Oh, yeah, my bad.
It's always the coefficient. It's never, the x never goes along with slope.
Mm-hmm. Yeah.
look at some geometry. What's angle X?
Sorry. Angle X would be 140.
Good. What's the length of AC?
Okay.
Forget reading this. You don't need to read any of these. I'll just ask you questions. In other words, all of this information is in the graph.
Mm-hmm.
So if anything, it just takes extra time and possibly confuses by reading it. Because there's nothing in here that you can't get by looking at this graph.
Yeah.
What's AC?
AC would be 7.
Do it again.
3 times 4, my bad.
No.
So it'd be 12.
No. It's the square root of what?
It's the square root of the, what is it? Square root of x minus.
It's the square root of the square, the sum of the squares of the two short sides.
Okay.
So it's the square root of 3 squared plus 4 squared, which is the square root of 9 plus 16.
9. Yeah.
Which is the square root of 25, which is what?
5.
That is a 3, 4, 5 triangle.
Yeah.
Think of all of the time you could have saved by just recognizing it. Then we wouldn't have had to go through that Pythagorean right triangle.
Okay. Yeah. Okay.
What is the length of AD?
Alright.
Hold on, let me move it over here so I give you a little bit of room.
Sure.
And I'm going to draw it because sometimes extra lines just get in the way in terms of expanding it. What's my base?
The base is 7 or 8. My bad.
What's AD?
AD would be the square root of 8 squared plus 4 squared. So it'd be 64 plus 16, which is 70.
80.
80, my bad. Yeah.
Now reduce that.
And then that would be x is equal to let me think. The square root of I'm just trying to think of what.
I'll help you.
Perfect square.
List the perfect square numbers starting with 1.
Okay. So that'd be 1, 4, 9, 16, 25,
That's all.
36. Okay.
That's enough. In other words, that's almost always enough. You don't have to reduce too many numbers that their perfect square is bigger than this. Okay, now, going through these numbers, we see that 80 is divisible by that.
Yeah, the square root of 4 and then the square root of 20.
Okay, so let's do it that way.
Okay, and then that would be reduced to 5 square root of 20. And then that can be reduced to...
Hold on. Where are you getting 5 from?
Oh, did I say 5? Sorry, it's 2 square root of 20. I was jumping ahead of myself.
Now reduce that.
And then that would be 2 square root of 4 and 5. And then it'd be 8 square root of 5.
Okay, what's that?
2 times 2, my bad. So it'd be 4 square root of 5.
Right. Now, notice that had I looked a little further, I would have seen that 80 is also divisible by 16. Exactly 5 times. So if I go back up here and I say square root of 16 times square root of 5, well,
then it is 4 square root of 5.
Immediately. So
saves a lot of steps.
Well, it saves 2 steps, but I want to also add that it wasn't necessary. We didn't have to do it that way. We could do it the way you did it. We'll just whittle it down each time. As long as you know to keep whittling. In other words, we did a problem at the start of tonight's session where we had this, you came up with square root of 8. Well, that
Yeah.
can be whittled down further.
Okay.
It's just advantageous if you can come up with the largest one.
Yeah.
In other words, when earlier I gave you that, well, gosh, that's divisible by 25 also. So
It is.
that's the square root of 25 times the square root of 8, which is 5 root 8. But then I got to whittle the 8 down.
Yeah.
So a lot of these can be done in multiple ways, and I think you can see where if you get the highest one first, you're going to reduce the amount of work you have to do.
Yeah.
But that list of perfect square numbers is a good list to be able to rattle off quickly.
Yeah, definitely.
What is the area of that triangle, ADB?
The area would be
not
32.
the one they're asking for. The problem actually asks for the area of this triangle. And let's do this. What's the area of this triangle only?
For that triangle only, it'd be 10.
Good. About the area of the whole triangle, the big one.
The area of the whole triangle would be 16.
Good.
Cool.
Yeah, really cool. Number 4.
Okay.
It's the similarity ratio.
The similarity ratio is
same thing as the
2 to 1. Yeah.
Linear ratio.
1.
Similarity ratio, linear ratio mean the same thing.
Yeah.
And you're right. It's 2 to 1. It's 6 over 3. That's what I'm comparing. I'm not comparing 6 to 7 or 6 to 8. I'm comparing 6 to 3. So now that I know the linear ratio, what's x?
So you would just do 2 to 1 times 8, which would be 16 over 1.
Does it make sense that x is 16?
No, it'd just be less, so it'd be 4 square root of 1, or just 4 to 1.
Just 4. Not 4 to 1, just 4. In other words, x is not 4 over 1. We're not talking about ratios. We're talking about side lengths now.
Okay.
But just make sure you don't go opposite directions. In other words, that's why I kind of emphasize always going big to little. The exact way to do this, in other words, if I had numbers that were more complicated than 2 to 1, it would be 6 is to 3 as 8 is to x.
Yeah.
That's the way I'm going to solve it. And now I can do a couple of things. I can cross multiply. 6x equals 24, so x equals 4. But in other words, if these numbers were something like 6.2 and 2.8, now the problem would become harder. You know, you'd need a calculator to do it, so it's important to be able to algebraically formulate it.
Definitely, yeah. Awesome.
It's not always going to be a nice, easy 2 to 1 ratio.
No, it's going to be different.
This is good, actually, because I didn't realize you really hadn't had triangles.
Yeah.
When I started looking in the book and I saw that the next chapter, chapter 9, was right triangles and chapter 10 was circles, I realized that we had actually gotten you quite a bit ahead.
Definitely.
But that's a good thing, not a bad thing.
Yeah, very good thing.
What's the hypotenuse on, what's the measurement of AC?
It would be 3. So it'd be 2 squared minus 1.
Your answer always has to start out with?
The square root of x is equal to the square root of.
What is it? The square root of what?
X is equal to the square root of 3.
Why 3?
It's 2 squared plus, my bad. So it'd be the square root of 5.
Good. Remember, when you're solving for a hypotenuse, it's nothing but addition that's going on inside the square root.
Okay.
When you're solving for a short side, it's nothing but subtraction going on inside the square root.
Yeah.
I'm ignoring all of this here. Don't even bother reading it because I'm asking different kind of problems. What's the length of AE?
Length of AE.
Kind of triangle is that? What's the first kind of triangle you should check to see if it is?
A right triangle.
Well, we know it's a right triangle. You're not going to get problems without right triangles. The title of this chapter 9 is Right Triangles.
Okay.
And so it's going to be a while before you have to worry about triangles that are not right triangles. So when you're trying to solve a right triangle, the first thing I want you to look for is this a 3, 4, 5 triangle?
Okay.
Is it?
It is, yeah.
So that side's 4.
4, okay.
Saves a lot of math.
Definitely, yeah.
What would the formula be if you had to figure it out? Square root of what?
The square.
Piece by piece. Square root of?
Oh, it's the square root of, my bad, my brain just went blank. 4 squared plus 2 squared.
No, it's 5 squared minus
3 squared.
3 squared.
Okay, it's a fine.
We're not solving for the hypotenuse. We're solving for one of the short sides.
Yeah.
That means there's nothing but subtraction going on.
Okay.
Okay? So the square root of 5 squared minus 3 squared is the square root of 25 minus 9, square root of 16. That's how that ends up being 4.
Yeah, that makes sense. Okay.
What's this figure called? The whole figure. A, B, C, D.
That's a trapezoid.
Kind of trapezoid.
Yeah. A regular.
Isosceles.
Isosceles.
Yeah, there's really no such thing as a regular trapezoid in terms of in terms of polynomials. Regular means all the sides are equal, all the angles are equal.
Okay.
So you can't really have a regular trapezoid. Okay? Because a trapezoid's definition is it has only one pair of parallel sides. In other words, BC is parallel to AD, and it's only one pair. And that being the case, you can't have a regular polygon with a trapezoid.
Okay.
But you can have an isosceles trapezoid. Where this side is always the same as this side.
Okay.
That's and that's the only other kind of, you can only have 2 trapezoids. You can have a trapezoid, or you can have an isosceles trapezoid.
Okay.
There's no really other kind of trapezoids. Okay. What's the relationship between angle A and angle D?
The relationship.
Huh?
Do
they have any relationship? Because it's an isosceles trapezoid?
Then they have to be congruent?
Yes.
Cool.
My favorite kind of problems. Number 6.
Okay.
And I say that because this is actually the ultimate geometry problem. Why? Because it has 2 triangles. One of them's a 45-45 right triangle, and the other one is a 30-60 right triangle. There's my 2 special triangles. So we're going to solve this problem
Okay.
So we're trying to solve for that, but we can't do it immediately.
Mm-hmm.
In other words, we first have to solve for AC.
Yeah.
Okay, so let's look at this triangle all on its own.
Okay.
What's AC?
Okay. So we're trying to find the two side lengths.
What do you have to do to figure this out?
We know it's a 60-30.
You got to be able to draw your unit one.
Oh, okay. Um,
This is the 30-60. This is the
okay.
45-45. You cannot solve this problem unless you memorize these two little triangles along with their dimensions.
Yeah.
What's opposite the 30?
That would be 2.
What do I call these? I call these
Okay.
my unit triangles.
Okay.
The reason I call them that is
Mhm.
because the side opposite the smallest angle is always 1.
Yeah, so it'd be, for the 60-30, it would be 1 on the side, 2 as a hypotenuse, and then square root of 3.
Okay. Now, that being the case, solve for AC.
Okay, so the ratio is 6 to 2, which is 3 to 1. So it would be 3 to 1 times 1, which would just be 3.
Okay. Now, we know this side, and now we're facing
The other side.
triangle. We're looking at this triangle here, which is a 45-45 that has a side length of 3, and that's all we know about it.
Mm-hmm.
But we have to figure out x.
Yeah.
So what are the dimensions of this little one up here on the upper right?
It would be 5 on the side,
No?
or, my bad, 1, 1, and then square root of 2.
Good. You do have those
Cool.
memorized. Okay. So, what's x?
Alright, so x would be the ratio of this 3 to 1, so you do 3 to 1 times the square root of 2.
Give me an answer.
So that would be,
As opposed to that. What you gave me was an explanation, which was correct, but it wasn't a final answer.
so it would be 3 square root 2
Good.
for x.
Good.
Cool.
Very good. The reason I love this problem is because you have to know both of these triangles to solve it.
Mm-hmm.
You have to do it step by step.
Yeah.
Now, I'm going to change some stuff.
Okay.
Now let's do it.
Okay. So that's the 60-31, so the ratio would be square root of 5 to 2 times, which side are we trying to find?
Well, same thing.
Same thing, okay. So for that one, it would be, so the ratio is square root of 5 to 2. So it'd be just square root of 5 to 2 times 1, so it'd just be,
Hold on. Let's stop.
times 2.
Let's stop for a moment. I think you kind of confuse yourself with your terminology. You had it absolutely right. Square root of 5 to 2. That's the similarity ratio. Now, what do I have to do to come up with AC? What do I have to multiply that similarity ratio by?
2.
No, by 1.
Oh, that's right, yeah.
Okay?
Because we're, okay.
Yeah. If I was trying to come up with this side down here, y, what would it be?
Square root of 3.
It would be the square root of 5 divided by 2 times the square root.
Times the square root. Yeah, my bad.
So this would actually be the square root of 15 divided by 2.
Mm-hmm.
Okay? So what I'm trying to point out is that it's no different. Everything is done exactly the same. That's why the process is so important. It's not the numbers that matter. It's the process. What we're doing is we're finding a similarity ratio, and then we're multiplying that similarity ratio by whatever the side of our unit triangle is. So this side here has to be square root of 5 over 2. Okay, now let's solve this for x.
Okay. So it'd be square root of 5 over 2 times, just times 2, right?
We're dealing with this triangle over here.
Times, oh, I was looking at the wrong one, my bad. Yeah, times the square root of 2.
Okay, so we got the square root of 5 over 2, which is the similarity ratio.
Times the square root of 2.
Square root of 2, what's that all equal to?
Square root of 10 to 2.
Okay, be careful how you say that. When you said square root of 10 to 2, I might have written it like this.
Square root of 10 over 2.
Yeah, and it's a minor point, but it's an important point. Square root of 10 divided by 2, not the square root of 10 over 2. Because when I say square root of 10 over 2, I'm going to write it like that 95% of the time.
Yeah.
Which is the square root of 5, which is not the same. Those two things are not the same. So,
yeah.
Okay. That's cool. That's really cool that you can do these similar triangles when one of them is a 30-60 or 45-45.
Awesome.
It's very helpful when you start right triangles, let me tell you.
Definitely, yeah.
The fact that you have mastered that.
Cool.
In other words, you could do this problem no matter what number I put right there. It doesn't matter whether I put a whole number or a radical number. You can still do the problem.
Yeah, exactly.
What's the area of a circle with a diameter of 8 inches?
Okay, so the area equation is area times pi r squared.
Area equals pi r
equals pi r. Yeah. And then the circumference
okay. We don't
equals
need the circumference on this, but go ahead and give it to me.
2 pi r.
Okay. So what is the area of a circle with a diameter of 8 inches?
So we would replace the area with 8.
No, it's got a diameter of 8.
Or the A. Oh, yeah.
We're talking about a circle whose diameter is 8.
So it'd be area is equal to pi. The radius is 4.
Okay, now go from there.
So it'd be area is equal to pi times 4 squared.
Keep going.
And then it would be area is equal to pi 16.
Always put the number first.
So 16 pi. Okay.
Okay.
Cool.
What other kind of stuff are you reviewing besides radicals?
Just radicals is really all we're doing right now.
Okay.
Yeah, he's given us a couple worksheets with nothing but radicals.
What percentage of the circle is this sector?
One here. Let me see.
What fraction? Not percentage, but what fraction?
It's 1/9 of the circle.
Okay. So what they want to know is what this little. Well, first of all, what's the area of that sector?
The area would be
the whole circle.
360.
No.
So it'd be 360.
What's the area of the circle? Pi r squared. What's the area of the circle?
Just
What's r?
R is 9.
It's 9 squared.
9, so 81. Okay.
81 pi. That's the area of the entire circle.
Okay.
What fraction of the circle does this sector represent?
1/9.
So what's the area of that sector?
So it'd just be 1/9 times 81.
Okay, keep going.
So that would be, what would that be?
It's 81 divided by 9.
Just 9.
Okay, 9 pi.
9 pi, okay.
So
Yeah.
9 pi is the area of that sector.
Okay.
Okay, what's the circumference of the entire circle?
The circumference would be 360.
2 pi r. I like the way you're thinking, but let's get our terminology correct. When I'm asking for circumference, what I'm asking for is the length of this circle. If this circle was made up of a piece of string and you were to cut it and straighten it out and measure it, that's what circumference means.
Okay.
Perimeter. Okay? It's not an angle. In other words, 360 degrees cannot be a circumference because 360 degrees is an angle.
Yeah.
Okay? So what's the circumference of this circle?
So the circumference would be
Just plug in r.
so it'd be 9, so which would be, so it'd just be 3.
2 times 9 is what?
18.
18 pi. That's the circumference of the entire circle.
Okay.
Wow.
So you just plug it in basically.
Every time. Whenever you're doing
Okay.
area or circumference and you have r, it's a piece of cake. As long as you remember your main two formulas. But
Okay.
I want the distance from A to B measured along the curvature. How far is that going to be?
Then that's just going to
In other
be,
words, the entire circle is 18 pi.
so that would just be 2. 2 pi.
2 pi. Good.
Cool.
2 pi.
Okay.
This problem come from? Somehow I got.
Interesting.
What kind of an equation can I write on number 5 in order to solve it?
5x is equal to, or y is equal to 5x, so just be 5x is equal to x. Y is equal to 5x plus x.
Forget everything you see here. Look just
Okay.
at that. Give me an equation that works.
X plus y equals 180.
Okay. Now, using substitution, let's go down here and see what y is.
So 5x, so it'd be 6x is equal to 180.
Okay. Solve that.
And then x would be equal to 30.
What's y equal to?
And then y would be equal to, that's equal to 30, 150.
Okay. In other words, you want to start these by figuring out the equation based on this. And then if they give us that y is equal to some number of x, then we can go in and start substituting.
Alright, cool.
What's x equal to here?
X would be equal to 50.
Okay. Oh, I know how I went backwards. I forgot. I'm actually glad I did. I wanted to do more angles than. I don't want to get too far ahead of what you're doing in class.
No, you're good.
Okay. What we have is a right angle.
The
And
transversal.
we have x is the same as y.
Mm-hmm.
In other words, that's what this says. X is equal to y.
Yeah.
So, what is true about this picture? First of all, tell me the lines. The lines are labeled with L's.
Uh-huh.
The lines are parallel.
L2 and L3.
Lines are perpendicular.
L1 and L2.
And what else?
And what?
Also L1 and L3.
Yeah, that too, my bad. Mm-hmm. Cool.
Don't have enough time to do that one. Although we can talk about it.
Sure.
What do I know about H plus A plus B plus C?
Wait, what? A plus B plus C plus D. Oh, H plus A plus B plus C plus D. Okay.
No, just those four.
We know that's equal to 180.
Okay. And H is the same as what?
H is the same as D.
Correct. So if H plus A plus B plus C is 180, then A plus B plus C plus D, because D is the same as H,
Yeah,
that
is
also has
180.
180. And this whole problem is kind of predicated on using vertical angles. In other words, what's the same angle as A?
E, English.
About C.
G.
Good. In other words, you kind of have to eliminate some lines from your mind when you do that.
Yeah, definitely.
Because you got all these lines here, and we're just looking for vertical angles. So C and G are the same, A and E are the same, B and F are the same, G and C, and that's how you're going to solve these, is just use those identities.
Awesome.
All right. That's a good session, Dylan. I'm proud of you. You've learned what we've been studying, and
definitely, yeah.
You have retained it. I wish they could give you a quick test on this material tomorrow, because you do pretty good on it. But you'll do fine once you get, especially if, I'm pretty sure they're going to start you out, as soon as you get done reviewing stuff, I'm almost positive they're going to start you out on right triangles and circles. So
probably, yeah.
You should be in good shape, because I think you know both of those pretty good.
Awesome. Well, that sounds good.
Dylan, have a good one. I will talk to you next time.
Sounds good. You too.
Bye-bye.
All right. Bye-bye.